Tell me. Tell me what a sequence is. Do you know? Okay, so you're right. It's a listing of numbers that we call terms that have a pattern. So maybe 1, 2, 3, 4, ... What does that mean? Continues in the same pattern forever and ever. Come on. And we'll come back. We're going to do sequences first, but just while we're here, what's a series? Does anybody know what a series is?
A series of numbers.
A series of numbers.
That repeat. Are they finite?
It can be finite or infinite. We're going to talk about both. Sequences can be finite or infinite.
They can?
Mm-hmm.
I did not know that.
Series though.
The World Series is the championship in baseball and softball.
A series sums the terms. In other words, instead of the comma there's a plus.
Wait, is this X, Y type thing? Or this table thing?
Can it be a subtract?
Huh? It just adds. It can add a negative though. All right, so listen. Several of you, we have talked about the pattern for just a second. The difference now is you have probably in the past done plenty of sequences where you classified based on the previous term, right? So in other words, you look at that first sequence and go, oh, they're just adding 1 each time, right? Well, when we get in a little bit higher math now, we classify them by their placement in the sequence. In other words, this is term number 1. So I have, if I do a sub n, that says the nth term in the series, okay? This would be a sub 2, a sub 3, and so on. Okay, so rather than classify them by the previous term, we're going to base the pattern. Ooh, pattern? What is wrong with me? Base the pattern on the placement in the series, the sequence. The reason for this is if I give you a sequence and you can figure out the pattern based on the term number, then if I say what's the 100th term in the sequence, you wouldn't have to write it out 100 times. You could just use your little formula to find it. Does that make sense so far? The hard part is finding that rule that works. Okay, so I think we'll start. I'll show you what the rules look like, and we'll write the sequence out, and then we'll practice writing the rule ourselves, which is the hard part. Okay. Let's say this is what it would look like. Here's a rule for a sequence. A sub n, so that means term number n, is going to be 2n plus 5.
This is random?
Mm-hmm. So I want you to tell me the first 6 terms of the sequence. So 1, 2, 3, 4, 5. I'm out of room 6. No. Why?
Because
what term number is this?
1.
1. So this is a sub 1. So I'm putting 1 in for n.
Where we get that from?
2 times more.
It's happening.
Plus 5 is 7. Wait, do you understand?
What would the next term be? 9. This is the third term, right? It always helps me, especially when I'm just seeing it, if I kind of write the numbers under so I can see.
Just add 2 different numbers.
That is what you're doing at this point. That's right. But the problem is, if I was just giving the set of numbers, having to actually come up with that equation for that pattern to start with, yeah, you got to do some thinking there. How about this one? Thanking the rule. Can we what? Oh yeah, we're gonna do something like that. Most definitely. We're gonna do sequences first, then we'll jump into series. They're a whole nother ball game, yeah. Write the first 6 terms of the sequence. They call it a rule. The formula for a sequence is called the rule of the sequence. Is that just the terminology?
So would that make your first
Exponent?
one, or your
No,
first
no,
number?
it's the end of subscript.
Yes, the ends of subscript.
But does it just multiply?
No, it's just saying that because we call the terms in the sequence, we say it's a sub 1, a sub 2, based on the placements. And what's the first term? I had to think a minute. Yes. Well, because I was thinking that I was thinking 0, so I was thinking there was gonna be 1/3. But what's the next one? 3. Wait. 1, 3, 9.
27.
27.
27.
That's all I know too.
3 to the first, second, third, 81. 1, 2, 3, 4, 5. Is it 343? 243.
79.
That's it. We can stop there. I said 6. That's 6. Stop. Do you see what we're doing? Easy peasy so far, right?
Yeah.
You just wait.
Mary. This one's from Mary. Sorry, guys.
To be fair, she was gonna do one like this anyway, guys.
Yeah, I know you would.
Your mission is to now write the rule. So here's what we're going to do. We're going to write a rule based on the term number itself. So my advice to you, so what I find the easiest anyway, is to write the actual term number under it, because sometimes it's just a little bit easier to relate that back and see the pattern. So, 2 to the 3rd is that? 3 to the 3rd.
Oh my gosh,
Oh my gosh.
But they need to be negative.
But they need to be negative. So how could I write that as an equation?
Don't do your exponent.
Negative n.
Equals negative.
Does that work?
Yes.
Does it work for every single one that we're given?
Yes.
Then we can call it a rule. What is the 20th term of the sequence?
I don't know what 3 1 times 20 is 400. 8,000 times 20.
Yeah, this is.
Holy stop!
Okay.
Get it out the dome.
That's the hard part of it.
What's the hard part?
She said, what happens if we can't see the pattern? Okay, here's another. This is just sequences, yes. We're starting out with some easy patterns.
That was such a fun game growing up.
All right, here's Joseph.
Fighting for your
I'm fighting for Joseph's attention. Remember, don't base it on the one before it. Base it on n. So if you need to come down here and say 1, 2, 3, 4. This one's a little bit harder. All right, so Ella says you add 2,
Which I know
then
that's
4, then 6. So you're adding the even numbers, but I don't want to relate it like that. I want to relate it to the green numbers.
I got it. I got it.
Do you? How did you get that? That's awesome. Students always get so mad in this section because the people that can see the patterns, and everybody else just gets so mad. How do you see that? All right, so n times n minus 1. Does it work for everyone? 3 times 2 is 6. 2 times 1 is 2. 4 times 3 is 12. Right? If this is n, then this is n minus 1. So what it's saying is take this n and the one before it and multiply it to get this. It's a little easier to see when you look at it like that, right? Or maybe you thought, that's not what I thought. I thought it was n squared minus n.
I got that. That's fine.
Same thing. Right?
Oh, because if you.
Or he's the same.
N to the third.
Does it matter? Does it matter how?
N to the third minus n to the second?
Yeah.
No. That's not going to work. No, this is just strictly intuitive. You're just looking. Let's do another one. This gets fun. I love watching y'all. All right. If and when you get it, do not blurt the answer out. Just wait. Look and see if you. No, shush.
What I'm thinking is might not be
I'm gonna. Oh, I forgot to record it. Ah,
Oh my
that
God,
is correct.
It's 2n over n plus 2. Joseph Burns found that.
Good job, Joseph. Good job. I'm gonna give you one. This is a challenge one. Y'all ready?
Okay, you look like you're struggling to write it.
Because actually what I'm doing is I'm looking at a rule, and then I'm looking at the answer that they have for the rule. Okay. Go, Kirkland.
2 to the n. And
Yeah, I got 2n to minus 3.
And parentheses, and then I did minus 3.
Minus 3.
Minus 3.
Yes, I got it. Yes.
All right.
I know, but that was after.
That was a really hard one.
But see, I only got it after I looked at that. So.
Yeah, I got it too after I looked at that.
Like, I wouldn't have gotten it.
Yeah.
I told you don't feel like that after the first section of this. Wait until we get through at least tomorrow's. All right, let me show you series. I know. Series are easy. Well, so series, the rules are formed the same way. It's just what it is you're doing. All right, so instead of n, we're going to use I.
Is that right?
I instead. Come on. And remember, the difference in a sequence and a series is a sequence just lists the numbers, a series actually adds them up, okay? Can I just get through? All right, so here's what we're going to do. We're going to use what we call summation notation. It makes me feel like I'm on Schoolhouse Rock. Summation notation.
I was like,
Again, we're going back to Greek. That's a big capital what?
Sigma.
Sigma, that's right. That tells us to sum a series of numbers. A lot of you have asked about my sign over my door with the sigma on there. It just means to sum, okay? So this tells us sum the following. I'm going to tell that to start at 1. So this is your start point. Up here is going to tell you where to stop. Okay, so start. This will make sense.
Is that a 4 on top?
Yeah. Stop when I is this. And then the rule is going to go here. Okay, so maybe I have, come on, 2I. Okay, so that is my rule. So this is saying that this particular series is, the rule is 2I. You want to start at 1, go to 4, and add them all together. Okay, so the first thing to do when you see something like this is to write the first 4 out, right? So the first one is what? 2. This one's a plus instead of a comma because it's a series, not a sequence. What's the second term? 4. The third term? And the fourth term. So this equals 20.
oh, I like this one better.
Okay? This, what we just did is the same thing as given the rule, write the series, write the sequence. We given the rule, we wrote the series. Okay, now we're going to have to go backwards and come up with the actual rule and write it in summation notation, okay? We all agree that's...
That little Greek thing doesn't even have really like any meaning. It's just like
it means to sum.
But it's really just like so we know where the numbers go.
It's how the problem is.
It means sum the terms 1 to 4. All right, what if I asked you? By the way, sometime I'm going to change the variable up because your book is changing the variables up a lot too.
My sigma of CC, I don't like
I'm sure I already know what
What if you were asked to find the sum of the series here?
That's -4, right?
That's equals 4. Sorry.
So it's the first
Sorry.
term.
You could keep going till 8.
So the first term would be, you got to start with 4 now, right? It's telling you start with 4 and stop at 8. So I'm going to do 4, 5, 6, 7, and 8. And I'm going to add them together.
On the last problem, why didn't we stop only at 4?
We did. Not when you get to the term 4, but when you get to the term number 4. That's why, so look at the numbers. I'm going to do term number 4, 5, 6, 7, and 8 for these. So I'm going to plug 4 into my equation. 16 plus 3 is 19. Plug 5 in. 25 plus 3 is 28. 6 in. Yes. Carry on, my wayward children. 49 plus 3 is 52. And then 64 plus 3 is... That's a lot of math. Yes, that's a lot of math. When you add all those numbers together, you get...
400.
205. Thank you for actually adding those instead of just randomly guessing. All right, so this is the easy part of series. Now let's look at the more difficult part of series and we'll be done.
I thought this was it.
Write a rule. All right, let's say I want to write this in summation notation. We'll start easy. Is this an infinite or a finite series? Why? It stops, right? It stops. Finite means it stops. It doesn't go.
And that's what we went to
All right.
Miss B always said.
I need a rule first. First, I need a rule.
Start a pod and
A rule. Remember, just like we did the series, the sequence rule, I need a series rule.
N plus 5.
N plus 5, will that work? This is, if this is N number 1, 1 plus 5 is 6, that doesn't work.
Times by
N
your
times
eye.
five. N times
eye.
five.
Times what by I?
N times five.
N times 5, that's right. Right?
I times
Or 5N or 5I, whatever variable you're choosing to use. All right, so we know that the rule is 5. We'll call it I since that's what we said we were going to start with. Let me move this down. Now the directions say to write it in summation notation. Okay?
No.
Any question mark?
All right, we're going to start at 1. We know 5I is our rule. The question is, where do I tell it to stop?
100.
100 is the value.
No, that would be 25.
What's 100
No,
divided?
25 times 4 is 100.
It's 20. It's 20. That's going to be the little extra part with the series that you didn't have with the sequence, is finding where it stopped. One more, a little bit harder. I don't know. Joseph, I'm fighting for your attention.
Specifically you and I'll
I'm not going to teach y'all the formulas for these rules because they're a little... you don't want them. I'd rather you just add them. All right, one more. Let's do... Ooh, y'all want to do a hard one? Let's do a hard one. This one's not that hard. I want you to write this rule in summation notation.
Do y'all not see how it's
What's different about this one? It's infinite. How do you say infinite?
infinity sign?
I'm getting out the rule though.
Did you already?
Yeah,
Wow.
I think so. Can I say it? No.
Right.
But I called this and said.
Say it.
I got
Why should you be wrong?
Go ahead.
I'm going to go ahead and set up my sigma here with my I equals 1 and my infinity because I know it's an infinite series, so I know it's going to be infinity at the top. All right, Ella, you got it?
Wait.
Okay. All right, I got several people that got it.
I don't have it.
What you got? Plus 1.
I almost
Wait,
got it. Okay, I was missing a square.
No, I got it.